NEC Article 695 addresses the requirements for generators serving fire pumps. The core principle is that the generator must have sufficient capacity to facilitate both the normal starting and the sustained running of the fire pump motor. Let's consider a specific scenario involving a 50 horsepower fire pump. The critical parameters are the motor's normal running current and its lock rotor current. In a given scenario, the normal running current is 65 amps, while the lock rotor current is significantly higher at 363 amps. The lock rotor current represents the maximum instantaneous current the motor draws during the brief starting period. The generator's capacity must be adequate to supply this surge of current without experiencing a voltage drop that could hinder the motor's starting capability. Once the motor reaches its operational speed, the current demand reduces to the normal running current of 65 amps. The standard explicitly states that the generator needs to be of sufficient capacity. This implies a detailed calculation and consideration of several factors. Firstly, the generator's continuous current rating needs to be equal to or greater than the fire pump motor's full load amps rating. In this case, the generator must be rated for at least 65 amps to handle the continuous running load. Secondly, the generator must possess the capability to supply the lock rotor current for the necessary duration to allow the motor to successfully start. This involves examining the generator's subtransient reactance and its ability to handle short-circuit currents. The generator's voltage dip during motor starting must remain within acceptable limits to ensure proper motor acceleration. The specific NEC article also addresses the tap ahead of the on-site generator disconnect means. Generally, a tap ahead of the generator disconnect is not required if the generator is sized to meet the requirements of Article 695. The code emphasizes the reliability of the fire pump system and aims to ensure that the fire pump receives power even during abnormal conditions elsewhere in the electrical system. The tap ahead of the disconnect is typically employed to isolate the fire pump circuit from potential faults in other parts of the system. However, if the generator is already sized to handle the fire pump's lock rotor current and running current, the additional tap may not be necessary. In a specific example, the generator is rated for 363 amps, which corresponds to the motor's lock rotor current. This implies that the generator has been selected to directly accommodate the motor's starting demands. In this case, a tap ahead of the on-site generator disconnect is not required. The absence of this tap simplifies the wiring and reduces the number of potential failure points in the system. The NEC provides further guidance on the selection and installation of fire pump generators. It is essential to consult the latest edition of the NEC and relevant local codes to ensure full compliance. The fire pump system is a critical life safety system and must be designed and installed with the utmost care and attention to detail. In summary, when evaluating the generator size for a fire pump, firstly, determine the motor's full load amps and lock rotor current. Secondly, select a generator with a continuous current rating that meets or exceeds the motor's full load amps. Thirdly, verify that the generator has the capacity to supply the lock rotor current for the duration needed to start the motor without excessive voltage dip. Fourthly, assess whether a tap ahead of the generator disconnect is required based on the generator's sizing and the specific requirements of the NEC and local codes. The evaluation of the generator capacity involves considering the motor's nameplate data, the generator's specifications, and the applicable NEC requirements. The motor's nameplate provides information on the motor's horsepower, voltage, full load amps, and lock rotor code. The generator's specifications include its continuous current rating, subtransient reactance, and voltage regulation characteristics. These parameters are crucial for determining whether the generator can adequately support the fire pump motor's starting and running demands. The selection of appropriate overcurrent protection for the fire pump circuit is also a critical aspect of the design. The overcurrent protection must be sized to protect the motor and conductors from overloads and short circuits while allowing the motor to start without tripping. The NEC provides specific guidelines on the sizing of overcurrent protection devices for fire pump circuits. It is essential to carefully follow these guidelines to ensure proper protection and reliable operation of the fire pump system. The installation of the fire pump generator must also comply with the NEC and local codes. The generator must be properly grounded and bonded to ensure electrical safety. The wiring methods and conductor sizes must be appropriate for the voltage and current levels involved. The generator must be located in a well-ventilated area to prevent overheating. Regular maintenance and testing of the fire pump generator are essential to ensure its continued reliability. The generator should be inspected periodically for any signs of wear or damage. The engine should be started and run regularly to verify its proper operation. The battery should be tested and replaced as needed. The transfer switch should be tested to ensure that it can automatically switch the fire pump load to the generator in the event of a power outage. In conclusion, the sizing and installation of a fire pump generator require careful consideration of the motor's characteristics, the generator specifications, and the applicable NEC and local codes. The generator must have sufficient capacity to start and run the fire pump motor reliably. The overcurrent protection must be properly sized to protect the motor and conductors. The installation must comply with all applicable safety requirements. Regular maintenance and testing are essential to ensure the continued reliability of the fire pump system. Article 695.3 of the NEC states that the fire pump shall be supplied by a source of power that is reliable and capable of supplying the required power. The power source shall be either one or a combination of the following: firstly, a dedicated service; secondly, an on-site power source; thirdly, a combination of a dedicated service and an on-site power source. In the scenario where an on-site generator is utilized as the power source, Article 695.6 of the NEC stipulates that the generator shall be of sufficient capacity to allow normal starting and running of the motor driving the fire pump. This requirement necessitates a thorough assessment of the fire pump motor's characteristics, including its full load current, lock rotor current, and service factor, as well as the generator's capabilities such as its continuous and short circuit current ratings, voltage regulation, and transient response. The generator's continuous current rating must be adequate to supply the fire pump motor's full load current, while its short circuit current rating must be sufficient to handle the motor's lock rotor current during starting. Furthermore, the generator's voltage regulation characteristics must ensure that the voltage remains within acceptable limits during motor starting and running, preventing nuisance tripping of overcurrent protective devices or malfunction of other equipment connected to the generator. In addition to the generator's capacity, the NEC also addresses the location and protection of the generator and its associated wiring. Article 695.6b requires that the generator be located in a room or enclosure separated from the other building areas by fire-rated construction. This requirement aims to protect the generator from fire damage and ensure its continued operation during a fire event. Article 695.6c mandates that the generator wiring be protected from physical damage and fire exposure. This can be achieved by using appropriate wiring methods such as rigid metal conduit or electrical metallic tubing, and by routing the wiring through fire-resistant pathways. Regarding the tap ahead of the on-site generator disconnect means, Article 695.3d of the NEC permits a tap ahead of the disconnecting means for the normal power source, provided that certain conditions are met. These conditions include that the tap conductors must be sized in accordance with Article 240.21c, the tap conductors must be protected from physical damage, and the overcurrent protective device at the tap point must be sized in accordance with Article 430.52. However, the NEC does not explicitly require a tap ahead of the on-site generator disconnect means. The necessity of such a tap depends on the specific design and configuration of the fire pump system. If the generator is sized to adequately handle the fire pump motor's starting and running current, and the generator wiring is properly protected, a tap ahead of the generator disconnect may not be required. Conversely, if the generator is not sized to handle the motor's lock rotor current, or if the generator wiring is vulnerable to damage, a tap ahead of the generator disconnect may be necessary to ensure the fire pump's continued operation during abnormal conditions. In the given scenario, the 50 horsepower fire pump motor has a full load current of 65 amps and a lock rotor current of 363 amps. If the generator is rated for 363 amps or higher, it is likely that the generator can adequately handle the motor's starting and running current. In this case, a tap ahead of the on-site generator disconnect may not be required. However, it is crucial to verify that the generator's other characteristics, such as its voltage regulation and transient response, are also suitable for the fire pump application. Furthermore, it is essential to consult with a qualified electrical engineer to ensure that the fire pump system complies with all applicable NEC requirements and local codes. In summary, the NEC Article 695 provides comprehensive guidelines for the installation of fire pumps, including the requirements for generators. The generator must be of sufficient capacity to allow normal starting and running of the motor driving the fire pump. The necessity of a tap ahead of the on-site generator disconnect depends on the specific design and configuration of the fire pump system. It is crucial to consult with a qualified electrical engineer to ensure that the fire pump system complies with all applicable NEC requirements and local codes. The fire pump system is a critical life safety system, and its design and installation must be approached with the utmost care and attention to detail. The overall goal is to ensure the reliable and uninterrupted operation of the fire pump, which is essential for protecting life and property during a fire event. Therefore, thorough planning, proper selection of equipment, and adherence to the NEC and local codes are paramount to the success of any fire pump installation. When evaluating the generator size, consider the temperature the generator will be operating in. High temperatures can lower the generator's output, so select accordingly. Also check the altitude of the generator. The higher the altitude, the lower the output will be. Another factor to consider is the type of fuel the generator uses. Diesel generators are more common for fire pumps as they are more reliable and require less maintenance. Also, diesel fuel is less flammable than gasoline. Be sure to check local regulations regarding fuel storage for the generator. The generator should have an automatic transfer switch that will automatically switch the fire pump to the generator in the event of a power failure. The transfer switch should be tested regularly to ensure it is working properly. The generator should also have a remote annunciation panel that will alert building personnel if there is a problem with the generator. The remote annunciation panel should be located in a constantly attended location. The generator should be sized to run the fire pump indefinitely. Some codes require the generator to be sized to run the fire pump for a minimum of 2 hours. Check with local authorities to determine the specific requirements. The generator should be located in a separate room that is fire rated. The room should be well ventilated to prevent the generator from overheating. The generator should be installed by a qualified electrician who is familiar with fire pump installations. The generator should be inspected and maintained regularly to ensure it is in good working order. The fire pump is a critical piece of equipment that can save lives and property in the event of a fire. By following these guidelines, you can help ensure that the fire pump will operate reliably when it is needed most. Remember to consult with local authorities and qualified professionals to ensure compliance with all applicable codes and regulations. The NEC is updated regularly, so it's important to stay current with the latest requirements. In addition to the generator itself, the transfer switch is a critical component of the fire pump power system. The transfer switch automatically switches the fire pump load from the normal power source to the generator in the event of a power failure. The transfer switch must be reliable and capable of handling the fire pump motor's inrush current. There are 2 main types of transfer switches: firstly, open transition, and secondly, closed transition. Open transition transfer switches briefly interrupt power to the fire pump motor during the transfer process. Closed transition transfer switches maintain power to the fire pump motor during the transfer process, which is preferable. The transfer switch must be listed for fire pump service. It must be able to withstand the high inrush current of the fire pump motor without damage. The transfer switch must also be able to operate reliably in harsh environments. The transfer switch should be tested regularly to ensure it is working properly. The testing should include simulating a power failure and verifying that the transfer switch automatically switches the fire pump load to the generator. The transfer switch should be inspected regularly for any signs of wear or damage. Any damaged or worn parts should be replaced immediately. The transfer switch is a critical component of the fire pump power system, and it must be properly installed and maintained to ensure reliable operation. The proper selection and installation of the fire pump generator and transfer switch are essential for ensuring the reliable operation of the fire pump system. A properly designed and installed fire pump system can save lives and property in the event of a fire. It is important to consult with qualified professionals to ensure that the fire pump system meets all applicable codes and regulations. The NEC provides detailed requirements for the installation of fire pumps, and it is important to follow these requirements carefully. In addition to the NEC, there may be local codes and regulations that apply to fire pump installations. It is important to check with local authorities to determine the specific requirements in the area. The fire pump system is a critical life safety system, and it must be designed, installed, and maintained with the utmost care and attention to detail. A properly designed and installed fire pump system can provide reliable fire protection for buildings and their occupants. When dealing with electrical systems, especially those related to life safety like fire pumps, it's always best to err on the side of caution and consult with qualified professionals. Their expertise can ensure compliance with all applicable codes and regulations, as well as the safe and reliable operation of the system.